Stabilize some perovskites, and you've got a sunny future ahead. Perovskite. 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 When somebody asks me what field involves almost every single type of engineer, electrical, materials, mechanical, civil, chemical, biomedical, even aerospace, one of the first fields that I think of that involves everybody is the energy industry, for sure. One of the more recent innovations in the energy industry involves perovskites. Perovskites specifically used in solar cells. What are perovskites? First of all, perovskite sounds pretty cool, I think, and it actually originates from geology. There's a mineral called perovskite, and I kind of have to do a shout out to a new Twitter account that I discovered called Geology Times, or in other words, Geology Tweets. They just post cool pictures of minerals all the time, and that's kind of awesome. So if you want to find out what perovskite looks like, maybe you could scroll through their feed at some point, or just Google it. In any case, there is this mineral called perovskite that occurs naturally, and it has a very specific crystal structure, meaning its atoms and its molecules pack together in a very specific, orderly way over and over. Well, the cool thing about that structure is that we can actually reproduce our own materials synthetically that have similar structures as that perovskite mineral. And in fact, any material that we create or that we find with that crystal structure is called a perovskite in engineering. So it turns out that these perovskite materials have a lot of cool properties, some of which include being able to help absorb energy from the sun. You put a layer of perovskite materials on a surface, on a panel, and the different electromagnetic waves from the sun hit it, and they transform that energy into electrical energy with a better efficiency than our traditional silicon-based solar cells. I just said a lot of words, so I don't know if you caught what I just said, but our old solar cells had like a 3% efficiency. Well, these new perovskite solar cells, they can get up to 30% efficiency, meaning 30% of that energy coming from the sun can be converted into electrical energy using perovskites. And that is incredible. I actually had a professor once who worked in the silicon-based solar industry for a little while, and he explained how complicated it was to create these silicon chips and silicon panels, because you gotta like process everything with vacuums and you have to wear clean room suits and really high pressures and temperatures, and everything has to be polished down, and it's just super expensive. Well, perovskites are actually way cheaper to make. You don't need these intense pressures and temperatures and all these other things to create perovskite solar cells. You just have to use basic so-called wet chemistry methods, stuff you can do in a typical chemistry lab, to deposit perovskite materials onto a panel. That is pretty amazing if it's cheaper and more efficient than the old way of doing things. So what's the problem with perovskites? Well, unfortunately, they're still a little fragile. There are lots of studies on the fragility of perovskite films and perovskite materials. They can get destroyed from different solvents and if you put too much stresses on them. But research is ongoing. There are some developments on pairing them up with other materials or other technologies to increase that stability. There's also innovations on making perovskite films more environmentally friendly too, to get rid of the lead that might be in some of them. So, as you go on into the future and hear more about more energy efficient materials that are easier to create and maybe more environmentally friendly, remember that perovskite was the engineering word of the day. Thanks for listening. This is your host, Pius, and if you like this podcast, you should also listen to the long-form podcast that I do called the K-12 Engineering Education Podcast. We just created a new website, so go on over and check it out at k12engineering.net. Again, that's k12engineering.net. Tune in next time.